Hi, hello everyone. Welcome back to our channel Samarth Official. In the previous video, you have learned about how to perform static structural analysis on a cantilever beam with point load acting at the free end. Please do watch the previous video if you haven't watched it. In this video, you will learn about how to find the maximum deformation and von Mises stress on a beam fixed at both the ends with point load acting at the center. Open ANSYS Workbench, go to Analysis Systems, go to Static Structural, select Static Structural, click on this and leave here such that it will create a standalone system. Okay, name this as Fixed Beam. Okay, select Geometry, right click, New Design Modeler Geometry. Okay, select any of the planes. I'll select XY plane. Select this, right click, look at. Go to units, select millimeter. Okay, click on sketching, select this rectangle, click here at the center, drag it and leave it here. So go to the dimensions, select this line, drag it and leave it, select this line, drag it and leave it. So you need to give V1 and H2 dimensions. Both are 20. Okay. Okay. Now click on extrude and thicknesses like the length of the beam, which is 100 mm. Okay. Select this. Select the extrude. Click on generate. Okay. So you can see here the beam is generated. Okay. Now file, close design modeler. Now select the model, right click, edit. Okay, you can see geometry is in tick mark, materials is in tick mark, and coordinate system is in tick mark, and mesh is in thunderbolt symbol. Okay, select mesh, right click, generate mesh. So it will create automatic mesh. Okay, mesh is created. Now select static structural, right click, insert. So as this is fixed beam at both the ends, you need to give fixed support at both the ends. So go to fixed support, select the space, click on apply. Again, just rotate this by clicking the center mouse button. Go to static structural, right click, insert. Again, fixed support, select the space, click on apply. Okay, you have two fixed supports, one at this face and another one at this face. Now you need to give point load at the center. Okay, so select static structural, right click, insert, force. Okay, so change this to components. You can see the force can be given in positive x direction. So select the space. The force is 1.5 kilonewtons, which is 1500 newtons. And you can see the question mark here. we have selected this face, but we haven't applied. Click on apply. Okay, the force is applied on the face at the center. Okay, you can see. So now click on solution, right click, solve. So the solution is solved, but you can't view the solution results. So for viewing the solution results, you need to go to post processing things. So select solution, right click, insert. So you need stress, equivalent von Mises stress. Select the solution, right click, insert deformation, total deformation. Okay, so select this solution, right click, evaluate all results. Okay, so you can see this equivalent stress. Okay, the maximum is in this position, like red color, and rest all colors indicates different von Mises stress. So select the total deformation. You can see maximum deformation is at the center and the value is 0.002143 mm. Okay, you can select this, click on this, so you can see this maximum deformation. Okay, so now you can try to change the load acting at the center. Load value, I'll give 2000 newtons. Okay, so after changing load, you can see these two has changed to thunderbolt symbol, static structural before and solution before. So we need to update this. Select static structural, solve. So you can see a green tick mark is created before static structural and solution. The solution is solved. So you can view the results. Click on equivalent stress. You can see the equivalent stress is changed, and click on animation. Click on total deformation. You can see the total deformation value is changed. Click on animation. Okay, again you can change the force value. So I'll give it as 3000 newtons. So you can see a thunderbolt symbol before static structural and before solution. So you can select any one of this, right click, solve. So you can see solution is solved, and you can see green tick marks before static structural and solution. Click on equivalent stress. Again equivalent stress value is changed, 22.209 maximum, and total deformation value is changed, 0.0042. Click on animation. Okay, thank you.